Welcome to today's talk. Today is Lazy Sunday, December 12th, 2021. Today, we're going to explain why the universe must be infinitely old. So, the first problem we must tangle is the Big Bang absurdity. Um, Edwin Hubble never agreed that his redshift discovery, which is an excellent barometer to measure the distance of how far the object was when it emitted the light. So we know that the universe is at least uh, 24 or 24 billion light years or 22 billion light years across as a minimum, okay? Because Edwin Hubble discovered the Hubble flow redshift, and this has been calibrated to a very, very fine number, okay? And the Hubble flow redshift, the cosmological redshift, correctly predicts how far a galaxy was when the light was emitted. So we have an excellent barometer to measure distance. Okay, the Hubble flow redshift. Okay, now where Lemaitre and Einstein and others went wrong was to consider that redshift to be Doppler redshift. So Hubble, for the entirety of his life, said, if you are believing that my discovery, the Hubble flow redshift, is Doppler redshift, then you are reading too much into the redshift, okay? So there are many ways that light over great distances is going to be redshifted. One is if it encounters any type of matter, and there's intergalactic gases, there's interstellar gases, and there's gravitational redshift. So there are many ways that light is redshifted as it travels. And this is a function, a clear function. And then there's the other issue from Fritz. Fritz Squeaky said that the light was tired. What that means is that light from 12 billion light years away, when it interfaces with light in our solar system or interfaces with light in our galaxy, it's going to be stretched, okay? Also, when you magnify light, you also redshift it. So part of the redshift that astronomers observe is through the machines themselves. The machines themselves redshift very weak light. The light in our galaxy redshifts light from far, far away because the intensity is stronger. Okay, it's an issue of very weak light, as Fritz Squeaky put it, an issue of very weak light against very strong light compared to our solar system. So these are the reasons that light shift redshifts. And that redshift through variable stars and supernovae has been calibrated so that you know exactly how far, or very close. I mean, you're talking in billions of light years here. So you know if it's 6.5 billion light years away, but you don't know if it's 6.55599 light years away. So the Hubble flow redshift, the discovery, the cosmological redshift, tells us exactly how far, approximately, how far away the light source was when the light was emitted. Okay? So we know that the universe is at least 22 billion light years across. Now, I say that the universe must be finite. And the reason that I say it must be finite is that in order for electromagnetic waves to propagate in a medium of GP1s I define as the smallest particle of mass in the universe. So first off, we know that sound waves, in order to propagate, have to be under pressure. Okay, if the density gets too low, and then the sound waves cannot propagate. Now, it's the same thing with light waves. In order to propagate in the GP1 ether medium of light waves, it has to be under pressure. For the GP1s to be under pressure, the universe has to be finite with matter and energy reflective edges. If the universe is infinite, then the cosmic microwave, all the waves generated in our universe would continue to propagate out to infinity. Now, astrophysicists try to confuse you by telling you that the cosmic microwave background radiation is radiation left over from the Big Bang. But here's the problem. They say in the Big Bang that a singularity put out all the mass and energy in the universe. Okay. Now this is absurd because you can't compact the universe into a dot. The only sack that can hold all the matter and energy in the universe is the universe sack itself. That's 22 billion light years, okay? You can't put all the mass and energy in a dot, okay? Now, there are many ways we know that the Big Bang theory is an absurdity, but it's in the textbooks. People get Nobel Prizes for the accelerating, expanding universe. Another absurdity. Galaxies are not moving away from us. They're not moving away from us at faster than the speed of light. They're not disappearing from our view. It's not possible, okay? It's physically impossible. Now, you may think that I don't believe in dark energy because they're saying that the expansion of the universe is powered by dark energy and that this dark energy composes 74% of the mass and energy of the universe. No, I know they have physical examples of dark energy. And the physical example of dark energy is the dipole repeller void that is pushing us at 290 kilometers per second towards the normal cluster, while the Shapley attractor is pulling us at 340 kilometers per second. So we have a push-pull. The reason we have this push-pull is that the Shapley attractor is a low GP1 ether pressure system, and the dipole repeller is a high GP1 ether pressure system, okay? And the difference is one of matter in the sense of nucleons, matter in the sense of electrons, matter in the sense of neutrinos. Matter is heating up in the Shapley attractor, and matter is cooling in the dipole repeller. Okay? So when matter heats up, you get gravity. Okay? And we know this to be a fact from the observations of bullet clusters. Now, bullet clusters are presented to us to prove the existence of dark matter. Okay? What dark matter is, the velocity of the stars around a galaxy are so great that they have reached escape velocity. So since physicists and astrophysicists believe that gravity is directly related to matter, they hypothesize that there must be more matter that we can't see, which they can't see as gas or stars. Okay? So that's where the concept of dark matter is. But gravity though it appears to be a direct function of mass and inertia, okay? Actually, it's a function of matter heating up. And as nucleons heat up, they net implode the structure of space. Let's review a little bit, okay? We say that God pumped God particle ones, the tiniest particle of mass in the universe, kept pumping the universe with these God particle ones until a pressure developed, okay? And then these God particle ones hooked up and they formed strands, and the strands combined to form strings, and the strings got woven into sacks. And that the smallest sac that we are able to measure is the electron neutrino mass energy vessel sac at about 1/1,000,000th the size of the electron. Okay, that's the tiniest mass energy vessel sac that we can measure. Now, there are only 4 indestructible mass energy vessel sacs that can permanently hold energy. That's the neutron mass energy vessel sac, the proton mass energy vessel sac, the electron mass energy vessel sac, and the neutrino mass energy vessel sac. What that means is only matter can contain both mass and energy, okay? You can't have energy separate from mass. Every form of energy that we know that is generated by those 4 particles, okay? It's generated by neutrons, protons, and electrons. It's we say there's hydrogen fusion in the star, and that's what generates the light and the energy for the star, okay? Matter and antimatter mix, and okay, that brings up another issue, okay? So, physicists say that protons and antiprotons are pulled out of vacuum. What I say is that a proton has its polarity reversed. Protons have magnetic moments, which means they're like a bar magnet because of their spin. Now, originally I thought their spin reverses, but a proton sac does not need to have its spin reversed. It just needs to have its polarity reversed. If you look down on the North Pole of a proton and it's spinning clockwise, okay, and let's say that's that spin makes it a proton. Then, if the polarity reverses, and now you look at the North Pole and it's spinning counterclockwise, well, that's an antiproton. So protons and antiprotons can flip if the polarity of their poles flip. It's a very simple process, okay? And neutrons, which decay into protons and electrons, are emitted inside neutron stars, and inside black holes is more neutronium, more than 3 solar masses of neutronium, and that neutronium, when it eventually warms up to absolute zero, is going to make like 36 times the let's say if you got 1 solar mass, then it could make 36 solar masses of hydrogen, because it has to warm up. It has to warm up from below 300 trillion Adoni Kelvin degrees absolute zero. Okay, so the neutrons and neutronium are degenerated neutrons, because the density is 5.52 billion metric tons per teaspoon, per 5 milliliters, okay? So at that density, it's very cold, okay? Because the entropy is low, the ability to bounce. Okay, so many subjects here, I'm going all over the board here. I forgot what, we were attacking the Big Bang Theory, okay? Well, let's explain gravity while we're doing it in the process, since we're discussing these mass energy vessel sacks. So the way a proton heats up, and net GP1s are compressed and imploded inside a proton mass energy vessel sac. And then that increases the pressure inside and increases the rate of pulsation. So that's how you get a hotter proton, and that's how you get higher frequency light. More GP1s from whatever the pressure is outside get compressed inside the proton envelope, and the rate of pulsation increases, and that's how you get a higher frequency light. So what physicists say is that the bounce between atoms increases, and that's how you get the higher frequency light. But the fact of the matter is that protons hover. They hover in the nucleus. They hover in neutronium of a neutron star. And it's this hovering and pulsation that creates the fly to a cathedral size of an atom. So as Rutherford explained it, the GP1 structured space between the nucleus, mass energy vessel, neutrons and protons, the space between them and the next atom, okay, is like a fly being in a cathedral, a couple hundred feet or a couple hundred meters. I mean, that would be a really big cathedral. Anyway, the analogy, a pea to a cathedral, no, it's a pea to a racetrack, or a fly to a cathedral, is the analogy between of the GP1 structured space. So nucleons pulsate. They pulsate these GP1s in and out, and the inertia, the mass of a proton is the result of imploded, compressed God particle ones of Planck length. They get imploded, and the more you implode, the more energetic the particle is, the quicker the pulsations, and the higher the mass. Okay, so we explain how mass increases as more energy, more GP1s are physically put inside a proton mass energy vessel sac. So you put the GP1s inside, that increases the pressure. Okay? Now we know this because if you shoot a high-powered laser at electrons, you change the electrons to muons. And then once they get away from the high-power laser, they decay back to electrons. And the difference, a muon has 207 times the mass of an electron, okay? So what happens is you pump these extra GP1s inside the sac gets bigger and bigger, and the holes that pulsate that in and out, okay? So electron sacs have a certain pulsation and when they have 511 kilovolts of energy inside, okay? Now you multiply that 207 times, the rate of pulsation increases, the holes are bigger, so you get gamma rays, so they can tell they have a muon because there's a quick release of gamma rays as it decays in 2/millionths of a second. So in two millionths of a second, a muon is going to decay back to an electron. Okay, so there are only 4 mass energy vessel sacs that can permanently hold both mass and energy. They're the neutron mass energy vessel sac, the proton mass energy vessel sac, the electron mass energy vessel sac, and the neutrino mass energy vessel sac. Now, once you get those inside, as a star compresses matter to lower and lower volume, then the electrons get pushed back into the protons and you end up with neutrons. But also as part of that function, neutrinos are blown up to the size of neutrons, except it's in a compressed form. Okay, so by blowing up neutrinos to the size of neutrons, the neutron, more matter, more future matter. Okay, you create more embryonic neutrons than you started with. Okay, so the embryonic neutrons in a neutron star are not just the hydrogen atoms that reabsorb their electrons. They're also freshly minted ones that take neutrinos and keep blowing them up till they become embryonic neutron sacs. Okay, and then once those embryonic neutron sacs warm up to absolute zero, then they'll decay to a hydrogen. Now, we don't know the exact ratio. I mean, think of these embryonic neutrinos like dehydrated onions, okay? So I think onions, it's like 8-fold. You take 1 pound of dehydrated onions, and then you end up with 8 pounds of hydrated onions. Now, since this neutronium is so dense and so cold, I mean, it could be 100. One solar mass of neutronium might make 100 solar mass of hydrogen, or it might make 1,000, or it might make 1,000,000. We don't know what the exact ratio is, but it's going to take infinite time for this to happen. It's going to take infinite time for the shapely attractor to transform itself to a dipole repeller void. Okay. I'm losing my voice, so we'll have to take this up later. Okay. Thank you so much for watching. Bye.